Hi, welcome along. Final topic in electricity. Not quite the final video because I think we'll split this into two. But what we're looking at here is an application of the knowledge that you already have really into some fairly practical day-to-day stuff. And the main focus of this video is circuits that could be used to control the brightness of a light bulb. So this is our first simple circuit to try and control the brightness of a bulb. We've got a power pack, power supply, battery, fixed voltage. We've got a resistor over here, and we've got a bulb. So the bulb is what we're trying to control, and the way we're going to control it obviously is just changing this resistance. So if I increase the resistance, you can say I can make the bulb dimmer and dimmer and dimmer, but notice the bulb hasn't gone off, and if I go the other way we can make the bulb brighter and brighter. So let's just stick the voltmeter in there, give us a bit more idea what's going on. So yeah, we've got the full 50 volts of the battery here because we've got zero resistance, and as we increase the resistance you can see we get less and less current, less and less voltage across the bulb because we've got more voltage across the resistor. But the problem is that we always hit this limit that we can never get this voltage down to zero. So as a control circuit, this isn't really the way to go. So what I've done is I've built another version of the circuit. So second attempt to create a circuit that allows us to control the brightness of the bulb. Got two resistors now, and that's handy because it's the ratio between the two resistances, the ratio of this bulb and resistor here and the ratio of that resistor, that's going to determine the reading on the voltmeter and the brightness of the bulb. So you can see now I've got a good range. I've already got a better range. I've got 50 down to 5.5 now. But it's because we can change this second resistance as well. You can see we can now get the full range of voltages. And what I'm going to do now is change to pen and paper to explain exactly how that would work before using a different tool to show you exactly how this would work in the real world.
I'm going to try and explain now about how these circuits might look or work a bit more in the real world. So we've got three terms here. Potential divider is the general name of a circuit using two resistors to divide up resistance. Potentiometer and rheostat refer to the actual component that can achieve this. So I'm going to try and draw a rheostat. They're generally a kind of big coil of wire. So you'll have what looks like a big solid black thing. That's actually a coil of wire with lots of resistance, and it will have a connection on either end. So if you connect between here and here, you've just got an ordinary resistor. But then we'll have another connection, and then that can slide backwards and forwards along here. So this becomes one resistor. So everything left of the contact here is one resistor, and everything right is the other resistor. So if we connect, call these terminals A, B and O. So if we use the terminals A and B, we just have a fixed resistor. If we use either A and O or B and O, we have a variable resistor. But when we want to use it as a potential divider or a rheostat, this is what we do. We connect our power supply to A and B, and then we connect our bulb or whatever we're interested in either between A and O or B and O. So as we slide that contact along, if we grab another colour, as that goes that way, R1 is decreasing and R2 is increasing. So the voltage here plus the voltage here must always be the voltage here. And the bigger R1 is compared to R2, the bigger the ratio, the more voltage we have here. So as we slide that contact that way, the reading on the voltmeter gets bigger and bigger until the contact gets there, and R1 is maximum and R2 is 0. If we slide the other way, then the voltage goes down, and when we get to here, we have no voltage. And I'm just going to show you that now in a simulation.
So the aim of this little simulation is just to show you the range of voltages we can get with a potentiometer or potential divider circuit. So if you look here, that arrow represents the end of the sliding contact. So we've got our wire or coil of wire. You can see there it says 100 ohms, 40 plus 60. So that's saying the total resistance, if we'd use the ends, was 100 ohms. We've divided it into the ratio of 40 and 60 ohms. The 500 ohms here is the resistor that we're investigating, and the 1.91 is the voltage that we're actually seeing, or the potential difference across that 500 ohm resistor. So I can now move this contact. If I move it all the way to the left-hand resistance, or R1, is 0. The right-hand resistance is 100, and you can see that written here. As I slide across, I make R1 bigger and R2 smaller, and as a result of that, the voltage reading on the voltmeter is getting bigger and bigger and bigger. And so, of course, when I get all the way to the right, then the reading on the voltmeter is equal to the 5 volts. If you look up at the top right in the green, the 5 volt is the original voltage of the power supply. I hope that makes things a little bit clearer.